In this video, I am going to solve these three questions, which is taken from the chapter 5, titled Force and Motion, Part 1. And these three questions are taken from the book Principle of Physics, 10th edition. Let's start the first question. A body has an acceleration of 3 meter per second square at 30 degree to the positive direction of an x-axis. So that means the particle have an acceleration a value. What's the value? 3 meter per second square. And its respective angle is given to the positive direction of the x as 30 degree. The mass of the body is given as 2 kilogram, and you have to find three answers. The first one, what is the x component of the net force? That means we have to find the value of f of x, and then the b part, we have to find the value of y component of the force, which is Fy, and then the third, we have to find what is the net force in unit vector notation. So once you found the answer for the first part and the second part, then we have to combine together to give the answer in the third part. So for this, what I am going to do, I am going to find the x component of the force. So how you can find the x component of the force? It's very easy. We know the Newton's second law, which is F, which is equal to m multiplied by a. This is the rule. So here we have x component and y component. So I am going to frame this equation for x component, as well as I am going to frame the equation for y component. So f of x, which is equal to max, f of y, which is equal to may, because the mass is a constant. So here the mass has just a value of 2 kilogram. So now I am going to apply the rule. We already studied this a of x from chapter 3. So I'm going to apply the rule from chapter 3, vector. So f of x, which is equal to mass multiplied by, how you can find the x component of the acceleration? The magnitude of the acceleration multiplied by cosine theta gives the value of the x component of the force. Likewise, the y component of the force is given by mass multiplied by the magnitude of the acceleration multiplied by sine theta. So now the first part of the question gives the answer here, and then the b part, we are going to find the answer here, and then we are going to merge this a and b together to get the answer for the third part. Clear? So now I am going to substitute the value. What is the mass of the object? The mass of the object is 2, and then acceleration here they mention as 3 meter per second square cosine of 30 degree. Likewise here, mass 2 multiplied by acceleration, the magnitude of the acceleration. So here they mention as 3 meter per second square sine of 30 degree. So what will be the answer? 2 multiplied by 3 cosine of 30 degree. So I got 5.19. What's the answer here? 5.196. So 5.196 I got. So I can round the value. 5.20 Newton. This is x component. So I have to put I cap. So this is the answer for the first part. Clear? Likewise here, y component of the force, 2 multiplied by 3 sine of 30 degree. We got the answer as 3. What's the answer? 3. 3 Newton J cap. This is the answer for our second part of this question. And then third part, we have to find what is the net force in unit vector notation. So what is the unit vector notation? Net force, which is equal to f of x plus f of y. Clear? So I'm going to take this value, I'm going to substitute here. What will be the answer? 5.2 Newton I cap plus 3 Newton J cap. So this is the final answer, the net force in terms of vector notations. Clear? So how we got the answer here? First we have to find the x component of the force, then we have to find the y component of the force, and then we are just going to add these together. Understand? Read the question. In the figure 5-36, let the mass of the block be 8.5 kilograms. So you have to see the diagram here. So we have the block of mass M, which is exactly kept over the inclined plane, and that surface is a frictionless surface, and the mass of the block is mentioned as, what is the mass of the block? 8.5 kilogram, and then the angle theta, which is 30 degree, and the surface between the block and the inclined plane is a frictionless surface, so no friction. So you have to find three answers. What are the three answers you have to find? In the first part, you have to find what is the tension produced in the cord or string. In the second part, we have to find the normal force. In the third part, if the wire, if the string, or if the cord is cut, what should be the magnitude of the acceleration? So these three things we have to find. So you have to, better I can draw the diagram again, because we have to draw the free body diagram. So you have a surface, and in that surface we have the inclined plane, and here we have the angle theta over the inclined plane. We kept the mass of M, and here we connected the block by using a string or cord, and this is the mass of the block, and we attach this cord to the wall, and now we have to draw the free body diagram, and this is a frictionless surface. So how to deal with the free body diagram? So we have to draw the forces. How many forces are acting on this block of mass? So we already studied exactly perpendicular to the surface, you will get a normal force, which is Fn, and this direction you will get a tension, because the tension is applied to the string, and this side and exactly to the downward direction you have the gravity force, and straight to this you will get mg cosine theta, because cosine theta always closer to the angle, and here this one is mg sine theta. So these are all the forces acting on this object. So why I just draw the free body diagram? Because here, especially in this chapter, you are going to get all the answer by using the force equation, which we get from the free body diagram. So if your free body diagram is correct, then the equations you are going to frame will be correct. So you should be very, very careful while you draw the free body diagram. So you have to see this. We are going to find the tension. So this is the tension. So this is my rightward force, and what is my leftward force? Which is exactly mg sine theta. We can easily, so rightward force which is equal to leftward force, the upward force which is equal to downward force, exactly straight to the upward force. What is the downward force? Which is nothing but our normal force. So I'm going to use this diagram for framing the equation. First question, we are going to find the tension. So tension, which is equal to, because this is tension is in the right side and mg sine theta is in the left side, so T, which is equal to mg sine theta. What's the value of the mass? 8.5 multiplied by 9.8 multiplied by sine of 30 degree gives the answer for the first part. So what's the answer? 8.5 multiplied by 9.8 multiplied by sine of 30 degree. 41.65 I got. 41.65 Newton. So this is the answer for the first question. Clear? Now we have to find the answer for the normal force. What is the normal force? As I already mentioned, normal force which is upward direction, and exactly straight to the normal force we have mg cosine theta. So Fn, which is equal to mg cosine theta. The mass of the object is 8.5 multiplied by 9.8 multiplied by cosine of 30 degree, which gives you the answer of the normal force. So 8.5 multiplied by 9.8 multiplied by cosine of 30 degree, we got the answer as 72.14. 72.14 Newton. So this is the answer for the second part. Now for the third part, we are going to find the acceleration. So what is given in the third part? Read the questions very carefully. If the cord is cut, so that means if the wire, if the string is cut, calculate its acceleration of the block. Calculate the acceleration of the block. So suppose you have to see the diagrams. You have to see the diagram, brother. You have to see here, and the upside of the plane, generally it is a x direction. This is a negative x direction. So because here the question they said calculate the magnitude of the acceleration. Clear? So the magnitude of the acceleration, we have to take the positive value, but generally when you cut the wire, when you cut the rod, the cord, the block will be accelerating down the slope. Am I right? So whenever you comes to the down the slope, it is in the negative direction of the x, up the slope is x, but that information is not given in the question. But anyhow, by seeing the diagram, we have the axis, x-axis and y-axis, positive x direction, negative x direction. So for that, we have to use this negative sign here. Understand? And all the times, whenever the question is related with the acceleration, you have to equate that term with the Newton's second law. Clear? So for calculating the third part, if you cut the wire, what will happen? The block will be accelerating. Which direction the block will be accelerating? This direction the block will be accelerating. That means it will be accelerating the direction of sine component, not in the cosine component. Clear? Understand? So I have to write minus mg sine theta, which is equal to the Newton's second law, because this is also a force and this is also a force. So I'm just equate these two. Why I put negative? Because this direction is the negative direction of the x, the upward direction is the positive direction. That information is not given. Generally, we have to use this concept. So I can cancel this mass with mass. Therefore, the answer acceleration, which is equal to negative of g sine theta, and the g value here they mention as minus 9.8 sine of 30 degree. So what's the answer? Minus 9.8 multiply with sine of 30 degree. So the answer here is exactly 4.9 meter per second, but the answer is in negative 4.9 meter per second square. But they ask you to give the answer of the magnitude. Am I right? So what is the magnitude of the acceleration? 4.9 meter per second square. So this is the answer for the third part. Clear? So here you have to be very, very careful, because all these equations for the three subdivisions, we took it from the free body diagram. Once, if your free body diagram is right, then the rest of the things will be perfect. Understand? So now we have to go for the third question. So better I will enlarge this. Read the questions very carefully, and we have to deal with the free body diagram also. So better I will do one thing. I will draw the diagram here. We have a pulley, and here this side we used a wire or string or cord which carry a block of M1, and this side also we have another mass M2. So this one is M1, this one is M2. Clear? Okay, now we have to draw the free body diagram. So better I will change the color. So how many forces? because both objects are exactly hanging by means of the string or cord. So you have only tension. So here in this direction, the tension, and here is the force due to gravity for first mass m1 multiplied by g. Likewise here, this is the tension, and this one is m2g. Clear? Now you have to just to see the first left side and the right side. In the left side, the tension is greater because the mass size is very smaller when you compare with the mass 2. So that means the left hand side, the tension has the greater value, where m1g has the smallest value. But when you come to the right hand side, so this is your left side, this is your right side. So in the right side, which one is greater? Because of the mass, it will be pulled down fast. So based on in the direction of the m2g, that means here in the right side, m2g has the greater value than the tension. So now what we are going to do, we are going to find something after we read the question. So we just read the questions very carefully. What's the problem? Okay. The figure shows two blocks connected by a cord that passes over the frictionless pulley. So the pulley, the frictions between the pulley and the cord is negligible because there is no friction. The arrangement is known as Atwood machines. The name of the machine is called as Atwood machine. One block has the mass of 1.3 kilogram, that is M1, and the another block M2 has the mass of 2.8 kilogram because the M2 is smaller than M2. Sorry, M1 is smaller than M2. So you have two subdivisions. In the first part, what we are going to do, we are going to find the acceleration of the block systems. We have two blocks, am I right? So we are going to find what should be the acceleration. In the second part, we are going to find what should be the tension generated in the wire or cord. Clear? So either you can say wire, or either if you want to say it's a string, no problem. But in the question they mentioned cord. So the meaning is exactly the same. Clear? Okay. Now, if you want to find the answer for this acceleration and the tension, then we have to frame the equation by using the free body diagram. So I'm going to write the free body diagram first for the left hand side and then right hand side. So what is the equations in the left hand side? Because both will have the acceleration, so both sides you have to deal with Newton's second law. So first of all, I'm going to write the equation for the left hand side by using the free body diagram. Tension, because here tension is the greater value than m1g, so that means we have to give the importance positive value for the tension. So tension minus m1g, which is equal to m1 multiplied by a, because we have to deal with the Newton's second law. Likewise, right hand side, I have to write the same equation like this, but this time your m2g is greater, so I have to give the importance for m2g minus tension, which is equal to m2 multiplied by a. So you have two equations. This is equation 1, this is equation 2. Now what I'm going to do, I'm going to find the acceleration. For finding the acceleration, I'm going to add both equation, both left hand side as well as right hand side. So I'm going to find the answer for the first part. So for that, what I'm going to do, I'm going to add equation 1 and 2 on both sides, That means if you add the left hand side, you have to deal with this left hand side of the equation, and here also you have to deal with the left hand side. If you add the right hand side, so right hand side m1a, here right hand side m2a. So I'm going to add both left hand side and the right hand side. So first of all, let's deal with the left hand side. So t minus m1g plus m2g minus t, because I simply added, which is equal to the right hand side m1a plus m2a. Clear? And now you have to see here the tension get cancelled with positive value with a negative value, and here we have the common term as a gravity. Therefore g, which is g multiplied by, I'm going to write this value first as a positive, minus m1, and likewise here the acceleration is the constant value m1 plus m2, and we have to rearrange this equation in terms of acceleration because we are going to find the acceleration. Therefore, acceleration A, which is equal to g multiplied by m2 minus m1 over m1 plus m2. So we have to use the value of m1 and m2. What's the value of m1? As we read the question earlier, what's the value they give? M1 has the value of 1.3, m2 has 2.8. 1.3, 1.3 kilogram, 2.8 kilogram. Clear? Now I am going to substitute the value here. So A, which is equal to G value is 9.8 multiplied by 2.8 minus 1.3 divided by 2.8 plus 1.3. So what will be the answer? Take your calculator. 9.8 multiplied by 2.8 minus 1.3 over 2.8 plus 1.3. What's the answer? I got 3.59. 3.59, and the unit for the acceleration is meter per second square. That means both sides the acceleration of the block is 3.59 because both are connected with the same chord. Am I right? Am I right or not? So the acceleration of both system has the value of acceleration 3.59. Now for finding the value of tension, because that is our second part of the question, you can use any one of the equation. If you want to use the first equation, no problem, you will get the answer. If you want to use the second question also, we will get the same answer. So better I can deal with the first part, and also I will show for the second part also. We have to compare. Both equation will give the same value of the tension because both blocks are connected by the same wire or same cord. So second part, better I write the equation here. T minus m1g, which is equal to m1a, and here m2g minus t, which is equal to m2a. So take any one of the equation for finding the value of t. So I'm going to take t here. I'm going to move this minus m1g to the right hand side. So what will happen? m1a, this minus, when it goes to the right hand side, this becomes positive. So m1 of g. So here m1 is the common term. So I take it outside. So a plus g. So let's substitute the value. As we already know, the mass of the first block is 1.3. And the acceleration is just before we found as 3.59. Am I right? So 3.59 plus 9.8. What's the answer for the tension? Take your calculator. 1.3 multiplied by 3.59 plus 9.8, 17.41. I got 17.41, and the unit is Newton. Clear? Okay. Can you please test the same for the second equation? Because as I already mentioned, if you use any one of the equation, you will get the same answer. Okay, I will show the answer for this equation also. So I'm going to move this tension to the right hand side. By that this become positive, and I am going to take this m2a to the left hand side. By that it will becomes negative. So therefore T, which is equal to m2g minus m2a. So I'm going to take m2 as a common term. So this time g minus a you will get, and we know the value of m2 is 2.8. 2.8 multiplied by 9.8 minus what is the acceleration which we got from the first part, 3.59. So let's check the answer. 2.8 multiplied by 9.8 minus 3.59. I got exactly same, 17.38. So I can write 17.4 Newton. So both answers are exactly correct. So if you use the left hand side equations or right hand side equation, your tension, because both blocks are connected by the same wire. Am I right? You have to see the picture here. You can see there is no another wire because we are using the same wire for both masses. So that means the tension created this side must be equal to the tension creating this side. Likewise, the acceleration of this m1, which is exactly equal to the acceleration of the m2. So that is the answer for this question. Clear? Thank you.